In this video, we're going to suppose that the p of x is 3x minus 4 and q of x is equal to negative 2x plus 1. We want to use those two functions to find the p of q of negative 2 and then the q of p of negative 2. And so this p of q and this q of p, those are composed functions. And what that means is you're putting one function inside of the other. And actually in this case, what we're doing is we're composing functions, and then we want to evaluate that overall composed function at a value. And so we can kind of use a little shortcut to make it a bit easier on us in a case like this, since we're looking for the p of q of negative 2 instead of like the p of q of x, for instance. And so let's go ahead and break down what we've got. And what I'm going to do is I'm just going to rewrite these problems. So the first one, we have the p of q. That's what that little circle symbol means, kind of like an O. It means the p of q. You're just putting one function inside of the other. Of negative 2. We're going to rewrite that as the p parentheses of q of negative 2. So since it is putting one function inside of the other, I'm going to write it in such a way that that's a bit more obvious to us. And so now what we want to do is we want to evaluate this, but what we're going to do is we're going to break it into two different problems. First of all, we're going to plug negative 2 into q, the original q function, and that's going to give us a number. And then whatever that number is, we're going to plug that into the p function, and that's going to give us the answer to this problem. So again, just breaking it into steps is going to make it a little bit easier, and you can do that since you're evaluating the composed function at a number instead of just a variable. So let's go ahead and figure out what the q of negative 2 is. So the q of x is negative 2x plus 1. So the q of negative 2 is going to be negative 2 instead of x. We're going to put negative 2 plus 1. So that's just putting negative 2 into the place of x. And if we multiply, negative 2 times negative 2 is going to give us positive 4 plus 1, and add that is going to give us a 5. And so we're going to put 5 in the place of q of negative 2. So now what we've done is we've reduced this problem down to finding the p of 5. And so now we're going to solve for the p of 5, and the way we're going to do that is we're going to put a 5 in the place of x in our original p function. So instead of 3 times x minus 4, we're going to have 3 times 5 minus 4. And then simplifying, that's going to give us 15 minus 4, which is going to give us 11. And so the answer to the p of q of negative 2 is going to be 11. And so now let's do the exact same thing for the q of p of negative 2, but the main thing you need to keep in mind here is going to be the exact same process, but you have to keep the order right, because if you mess up on the order, you're going to mess up on the problem. And so just again, we're going to rewrite this instead of the q of p of negative 2, we're going to rewrite this as q on the outside, parentheses p, parentheses negative 2. So this time, even though we're doing the same thing, we're going to plug negative 2 into p first, and then we're going to get a number. And so we'll switch out the p of negative 2 for that number, and then we're going to plug that number into q to get our overall answer. And so let's go ahead and plug negative 2 into the place of p. So the p of negative 2, p of x is 3x minus 4, so the p of negative 2 is going to be 3 multiplied by negative 2 minus 4. And 3 times negative 2 is going to give us negative 6, minus 4 more is going to give us negative 10. And so we're going to put negative 10 into the place of the p of negative 2. And so that reduces this problem. Instead of finding the q of the p of negative 2, we're now finding the q of negative 10. And so that's just going to involve plugging negative 10 into our original q function. So the original q function is negative 2 times x. So we're going to have negative 2 multiplied by negative 10 plus 1. And then simplify. Negative 2 times negative 10 is going to give us positive 20 plus 1 is going to give us 21. And that's going to be our answer for the q of p of negative 2. Now there's another way you could have gone about this problem. If you wanted to figure out what the p of q was just using x's and the q of p was using x's, you could certainly do that. You could compose the functions and then you could plug in the value negative 2 in each case and you would get the same answer. But personally, I think it's a little bit faster and a bit easier if you compartmentalize these problems and you just rewrite it as the p of q of negative 2 or the q of p of negative 2 and then work from the inside out. So again, the main thing to keep in mind here, it's not really hard, just some algebra, but you definitely want to keep the order right. Whichever function is the first function, that's going to be the one that's on the outside. So just keep that in mind and you should have no problems.